Greetings. Here we are with your second recording. We have this lovely bullet down here, and that bullet's going to be, well, traveling at an initial velocity of 21 meters per second, right? So we have this initial velocity, which we're going to call VI, of course, and that's 21 meters per second. We also are going in the vertical realm, so A equals that of gravity, which is negative 9.8 meters per second squared. The question is, what is the height the bullet reaches 1.2 seconds after firing? So we also have a time period in which we have a time of 1.2 seconds. And so we have these pieces of information, and ultimately we're looking for change in distance. So let's find an equation that'll work for us. And I believe we have something that says delta D equals VI delta T plus 1/2 A delta T squared. And we have everything but delta D, so this one's quite friendly in the fact that we can just put some numbers in. I'd say 21 meters per second. Multiply that times 1.2 seconds. And then I add to that 1/2 times negative 9.8 meters per second squared, and multiply that times 1.2, 2, and we square that. And you're going to get delta D from that, right? And that delta D ultimately will be 25.2 meters. Voila, part A. Very nice indeed. Part B, I'm going to take a step back. And for part B, here we are looking at, well, now we want to know how many seconds it takes for the bullet to go 12 meters above the muzzle of the gun. Well, we just came up with the fact that 25.2 meters traversed in 1.2 seconds. So you figure it's got to be less than 1.2. In fact, it's probably close to half that, because we're going more or less half the distance if you look at the numbers. This is assuming our 25.2 is correct, which it is. So now we're looking for a new piece of information, and we know we have a change in distance unrelated to the first part of the question, which is 12 meters. We still are going vertically, so A should equal negative 9.8 meters per second squared. And that's all the information we really have, I believe. We want to know how many seconds it takes. We know a distance, so this one's a little bit tricky. There's a couple different ways we can do it. We actually, oh, wait a minute, we have a VI, and that VI equals 21 meters per second. Now, we could use an equation that looks like so, right? We could say, well, delta D equals VI delta T minus 1/2 plus 1/2 A delta T squared. And we have everything but T. But what's going to end up turning out to be a quadratic. We have to do the quadratic formula, and that you guys might shy away from, I'm thinking. We could do that, but I have something that might be a little easier. And the fact that if we could find out a final velocity, then we could use two separate equations. And I think we can find out a final velocity if we do something like this, VI squared plus 2A delta D. Now we know delta D, we know A, we know VI squared. Well, we can put those numbers in. And so VI squared, well, we have 21 meters per second. We can square that value plus 2 times a negative 9.8 meters per second squared times a change in distance, which we find is 12 meters. And then we will take the square root of this entire thing. Let's see how good I can do that. Whoa, there we are. And that whole thing, the VF, ends up being 14.3 meters per second when you press the right buttons on your trusty calculator. Then, if we're looking for a time period, we can use another equation that says VF equals VI plus A delta T, and solve for delta T, in which VF minus VI all over A should equal delta T. And let's put some numbers in. We know that VF is 14.3 meters per second, which we just solved minus a VI of 21 meters per second. And our acceleration is negative 9.8 meters per second squared. And ultimately, we do all this out, and we get 0.68 seconds. And that's a beautiful thing. You know why it's so great? It's because, take a look. Initially, our first part, we went for 1.2 seconds, right? And during those 1.2 seconds, we traveled around 25 meters. Well, now, for half the distance, it should take roughly about half the time. And look at that lovely number. Half about of 1.20 seconds. Enjoy listening. You have yourself a great day.